A grown animal the size of a refrigerator sits in a cold mountain forest, chewing. It has the gut of a carnivore, the teeth of an omnivore, a thumb that is not really a thumb, and it spends almost its entire life eating one plant, bamboo, a food so poor that this bear has to chew for most of the day just to stay alive. It moves slowly. It breeds slowly. Its babies are born absurdly small. Its world keeps shrinking. Did evolution fail pandas? Because pandas look wrong in a way few animals do. Less like a polished adaptation, more like an emergency patch. A meat-eater somehow trapped inside the lifestyle of a herbivore. And by the usual story we tell about natural selection, animals this awkward are supposed to lose. So why didn't they? The first mistake is thinking evolution works like an engineer. It doesn't design the best possible animal. It doesn't plan ahead. It doesn't care whether a body looks elegant, efficient, or ridiculous to us. It keeps whatever survives long enough to reproduce in a particular environment, even if that body looks like a compromise held together with spare parts. And pandas really are spare parts animals because they carry two histories at once. On one level, a giant panda is still obviously a bear. Its ancestors came out of carnivora, the mammal group shaped by meat-eating ancestry. Pandas still carry a lot of that old equipment. Their digestive tract is short and simple compared with the giant fermentation systems used by dedicated plant specialists like cows or deer. They do not have multi-chambered stomachs. They are not especially good at digesting cellulose. Under the hood, they still look like animals that were never fully rebuilt for leaves and stems, which makes the panda lifestyle seem almost absurd. An adult panda can eat 20 to 40 pounds of bamboo a day and spend 10 to 16 hours doing it. So why choose bamboo at all? That is the real puzzle, because bamboo is not premium food. It is fibrous, tough, and relatively low in calories. Most herbivores solve that problem by becoming fermentation specialists. They digest slowly. They strip out as much energy as possible. Pandas do not. Food moves through them fairly quickly, and they get less out of it than a proper grazing animal would. By human standards, this looks like a terrible plan, and yet pandas have survived this way for millions of years. So what are we missing? In the mountain forests of China, bamboo offered something more valuable than richness. It offered reliability. Meat runs away. Fruit comes and goes. Nuts fail. The best foods attract competitors from every direction. Bamboo can grow in dense stands over huge areas, across different elevations, and in many places it remains available year-round. It is not glamorous food, it is dependable food. And if you can build your life around a resource that most other large mammals mostly ignore, you get something precious: room. This is where pandas usually get misunderstood. We picture them as bears too incompetent to live like normal bears, as if bamboo were some sad consolation prize. But from another angle, pandas escaped competition by specializing in a lane that was wide open. While other animals fought over richer foods, pandas leaned harder and harder into the one resource that was almost always there, that came with a price. Once the lineage committed to bamboo, evolution had to work with bear parts and make bear parts better at handling stems. It could not start over. It could only modify what already existed. So the skull became heavier, the jaw muscles became enormous, the molars became broader and tougher, better for crushing fibrous plant material. And then there is the most famous panda feature of all, the so-called thumb. A panda does not have a true opposable thumb like a monkey or a human. It has an enlarged wrist bone, the radial sesamoid, reshaped into a gripping tool. It works with the paw like a clamp, letting the animal hold bamboo stalks and strip them with surprising control. If you looked at a panda skeleton, you would see a wrist bone sticking out beside the paw like a sixth finger that evolution bolted on after the fact. This is one of the clearest examples of how evolution actually works, messily. If a primate were built for this job, it would use a real thumb. A panda is not a primate. It is a bear lineage under pressure to manipulate food more efficiently, so evolution grabbed a spare wrist bone and turned it into a fake thumb. Not elegant. Effective enough. And effective enough matters far more than elegant ever will. In fact, one of the strongest arguments against the idea that pandas are evolutionary failures is time. They have been doing some version of this for millions of years. That matters because truly disastrous designs do not usually persist on evolutionary timescales. A species can be vulnerable. It can be weird. It can be over-specialized. It can even look comical, but if a lineage survives for millions of years, then in the only currency evolution really cares about, it has been working. So where does the image of the panda as a biological disaster come from? Mostly from reproduction, because pandas have some of the worst public relations on Earth. They are famous for breeding poorly in captivity. Females have a very narrow fertile window each year. Cubs are born tiny, shockingly tiny. A mother that can weigh around 200 pounds gives birth to a newborn that weighs only about 100 grams. Relative to the size of the mother, that is one of the smallest newborns of any placental mammal. A 200-pound bear producing a newborn that weighs about as much as a stick of butter does not exactly radiate evolutionary confidence. So is panda reproduction actually broken? Not really. What is broken is the setting where humans often judge it. These are solitary animals with very specific signals, timing, movement patterns, mate preferences, and stress responses. Put them in artificial enclosures, limit their choices, surround them with human noise and constant management. A system that evolved under very different conditions starts to malfunction. That does not mean the species forgot how reproduction works. It means captivity is a bad test for an animal built for another life. Still, pandas are not prolific. They are not built for rapid population explosions. Females are fertile only briefly. Cubs are fragile. Mothers invest heavily. This is the strategy of an animal living in relatively stable habitat, where the goal is not to flood the landscape with offspring, but to survive steadily inside a narrow niche. And that strategy only works if the niche stays intact. For most of panda history, that was enough. Then the landscape changed faster than any panda could keep up with. Forests were cut, valleys were cleared, roads split habitat apart. What used to be one connected mountain system became scattered patches. And a specialist this narrow doesn't have much room to absorb that kind of shock. Even bamboo itself adds danger on its own terms. Many species flower and die off in cycles, sometimes across huge regions. In an intact landscape, pandas can just move, shift elevation, switch patches, switch bamboo species. In a fragmented landscape, that flexibility collapses. A road can do it, a town can do it, a dammed valley can do it. Any of these can turn a temporary shortage into a dead end. Did evolution fail pandas? Or did pandas become extremely good at one narrow version of life, only to meet a world where that version was being dismantled? Because pandas are not unusual in being specialized. Koalas live on toxic eucalyptus leaves. Anteaters gave up teeth and feed through a tongue like a living hose. Sloths move so slowly that whole little ecosystems can live in their fur. The panda's problem is not that it is weird. The problem is dependence. A specialist can thrive for millions of years while its niche stays stable, but the more tightly a species is tied to one resource, the more vulnerable it becomes when that resource is fragmented. That is the real limit of natural selection. It is always solving the present with the leftovers of the past. It cannot see highways coming. It cannot anticipate chainsaws, dammed rivers, or a civilization rearranging mountains in a few centuries. Pandas were shaped for one world and then pushed abruptly into another. Even so, they have proved more resilient than the stereotype suggests. There was a time when wild panda numbers were dropping so badly that extinction felt plausible within living memory. But conservation in China, habitat protection, anti-poaching enforcement, reserve expansion, ecological corridors improved the situation enough to shift the panda's official status from endangered to vulnerable. That does not mean pandas are safe. It means they were never too broken to save, and that matters because calling pandas an evolutionary failure does something subtle. It makes their decline sound inevitable, as if the species had always been doomed by bad design. But extinction is often not a verdict on incompetence. Sometimes it is what happens when a highly specialized animal meets change faster than adaptation can respond. So no, evolution did not fail pandas. It built exactly the animal that one mountain forest needed. Not perfect, not flexible, not future-proof. Good enough for as long as that forest stayed whole. The tragedy is that the mountain changed faster than the panda ever could.